natural gas. If the natural gas contains H2S, CO2 and water content also, this term doesn't store natural gas. What will happen if acid gas is present in the natural gas? It will cause corrosion, it will reduce heating value, and it will reduce sale value. Sale value indicates the product that has to be sold to the customers or consumers. Okay, before sending it to the consumers or customers, make sure that the natural gas is pure. So, before carrying out the purification process for the enhancement of the production of the natural gas, the first step what we need to do is we have to remove the impurity present in the natural gas. How it can be removed? Before talking about discussing about how it can be removed, what will happen if H2S and CO2 is present in the natural gas? If you are going to work in a natural gas regasification unit or natural gas processing unit, once you receive the natural gas from the offshore, the first step from your end is to remove the H2S and CO2. Okay. There might be many engineers who may work in natural gas regasification unit. Okay, there is some permissible limit. There is some permissible limit for the leakage to happen in every industry. Okay, so what will happen if 0.13 ppm of the acid gas is released? If 0.13 ppm of acid gas is released from the natural gas, what you can do is you can able to notice a unpleasant odor. Okay, this odor you can notice up to 4.6 ppm. As the concentration increases from 0.13 to 4.6 ppm, okay, the odor will the bad odor here, it indicates it will be like a rotten fish odor. Okay, it will be like a rotten fish odor. Okay, as the concentration increases at one point, what will happen is you cannot able to identify the odor, but the leak will happen continuously. Okay, so if leakages happen, if there is any agents are there to detect the leak, yes, we have agent. Okay, we will discuss about what are the agents that is being added to detect the leak. And if the concentration, if the proportion of H2S and CO2 exceeds more than 10 ppm in industry, okay, up to 10 ppm, it is allowed by occupational safety health standards prepared by USA. Okay, that is followed in almost worldwide. Okay, this OSHA standard is being followed worldwide, and they have clearly mentioned that a leakage up to 10 ppm is permissible. Beyond that, it is not allowed. Okay, if the permissible limit exceeds more than 10, for example, if it reaches 50 ppm, what it will happen is okay, uh, it is not possible for an engineer to work 12 hours or 16 hours continuously. If the leakage happens if the leakage happens, and if you have identified that the leakage is up to 50 ppm, that is the proportion of H2S and CO2 that is being released is up to 50 ppm. In that case, make sure that the engineer has to leave the industry by 8 hours. Okay, what will happen if he stays more than 8 hours? Okay, he will get throat irritation followed by some other symptom. We'll discuss what exactly it was. If the proportion of H2S and CO2 release is more than 100 ppm, you will get coughing, eye irritation, loss of smell for a period of 3 to 15 minutes. Okay, for a period of 3 to 15 minutes, if the proportion exceeds more than 100 ppm, coughing, eye irritation, and loss of smell happen. Then after 15 minutes, what you will feel is you will feel altered respiration has been mentioned. Okay, you will feel a difficulty in respiration, pain in eyes, and drowsiness. Okay, it continues for a period of more than 1 hour. Okay, the reason why I'm testing here is you will get questions related to the psychological effects when the percentage of H2S and CO2 that is released in the industry is quite high. What will happen to the person who are working in the industry? So you should aware. Okay, there are different permissible limits are there. If it exceeds beyond the permissible limit, what will happen? If it exceeds more than that 100 ppm and 200 ppm, you should be aware of what's happening in the industry and how they manage it. And more than 50 ppm, it is difficult for you to control. The only thing what you can do is you can get away from the place. Okay, some 6 kilometers radius away from the place where the industry is located. If the leakage happens and if the proportion of H2S and CO2 release more than 50 ppm, always make sure that you should be away from a place, away from the place where the industry is located. Okay, this distance should be more than 6 kilometers. if the percentage of H2S and CO2 release is more than 200 ppm, obviously it kills the smell, it kills the sense of smell, okay, and you will have burned eyes and as well as the throat irritated, okay, all these will be severe. And there are many cases where we have seen the when the leakage happens, where the H2S and CO2 proportion is released to more than 500 ppm also. If it is 500 ppm, ultimately you will get dizziness and you will lose sense of reasoning and balance. Then you will feel breathing difficulties, and sometimes you need to be taken into the hospital and should be put in a ventilator support for to ease your breathing difficulty. Okay, if the proportion exceeds more than 700 ppm, okay, if it exceeds more than 700 ppm, obviously you will lose the consciousness, okay, and breathing will stop, and ultimately it will result in death. Okay, sometimes what will happen is, okay, you will be in a coma, and ventilator support is much required. And latest some of the technique that has been implemented in medical industries, ECMO, other than ventilator support, they will give there is an instrument called as an ECMO, ECMO, okay, that gives an additional that will pump the pure oxygen in, and it will take the bad carbon dioxide out. That is the role of that particular equipment, and which is almost all the uh, petroleum refineries, chemical industry will have at least one or two ventilator support or ECMO support is provided. Okay, in an extreme case where the percentage exceeds more than 100 ppm, what will happen is you will get unconsciousness immediately. Okay, and it will lead to permanent brain damage or death. Okay, and you should be given an artificial life support. So depending upon the proportion of H2S and CO2 that is being released in terms of ppm, okay, the type of disease that is occurring to the persons who are working in the industry will vary. Okay, there are different processes are there for the recovery of H2S and CO2, that is called as an acid gas present in the natural gas. And the first we have is chemical solvent. When we talk about the chemical solvent, we can use monoethanolamine, diethanolamine, triethanolamine, mono diethanolamine, MDEA, then diisopropanolamine, okay, which is called as a shell addict process. Okay, then DGA, diglycolamine, it is termed as a fluoreconomine process. Okay, some of the different names you have, okay, don't think that it is a solvent name. No, it is the name of the process. Okay, depending upon the country, they have captioned accordingly. And we have proprietary amine, okay, hot amine, and like rich amine, lean amine, so amine solution. Then we have hot carbonate salt, which is heated, and it can be used for the recovery of H2S and CO2. Okay, Benfield process, then Katagap process, then Gammarco Vetroco process. All these processes use hot carbonate, but each has filed a patent separately depending upon the efficiency of the H2S and CO2 they remove. Okay, then we have Diamox process, then Dravo-Still. When we talk about physical solvent, we have Seluxol, Rectisol, Purisol, Spasol, propylene carbonate, ester solvent, and alkazate. Okay, only propylene carbonate is the solvent that has been used in one of the company, and they have named the process itself as propylene carbonate process. Another company has named a different name. Other company has named in different terms. And finally, we have direct conversion, which is iron bond, Tetford, Unisulf, Takahash, Locat, Lassie Keller, Townsend, Sulfine. There are some more chemical solvent, physical solvent, and direct conversion processes are there. And we have specialty solvent. In chemical solvent, we have a normal one and a special solvent. In a special solvent, we have Amisol, Flexol, then Celifining, Eucarsol, Optisol, zinc oxide, sulfur slurry suite, chem suite, Merox. When we talk about the physical solvent, we have distillation process, Ranholm process, and thyrofrac process. Discussing about the direct conversion, we have gas permeation, membrane, and molecular sieve. See, we have more than some 20 processes in each, and in physical solvent we have 10, and direct conversion we have 10. Okay, we are not going to discuss all in each, we are going to discuss 5. Okay, in each of the process of chemical solvent, physical solvent, and direct conversion process, okay, we will discuss maximum of 5 and a minimum of 3 to 4 processes. Okay, and when we talk about how many number of flow sheets are there in acid gas removal process, okay, you will have 6 flow sheets. You will have only 6 flow sheets, but we will discuss around some 15 topics. Okay, together in physical solvent, chemical solvent, direct conversion process, we have 15 topics to be discussed, and only 6 flow sheets are there. In the same flow sheet, we will use different solvent. What will happen when solvent is changed? Okay, all this we are going to study in the forthcoming class. We have seen what are the different processes are there for the recovery of the acid gas. When we talk about the iron sponge, sulfatrate and zinc oxide, it will remove only the H2S present in it. But when it comes to molecular sieve, it removes carbon dioxide, H2S, RHS is mercaptan, then carbonyl sulfide and carbon disulfide. Okay, carbonyl sulfide and carbon disulfide. All these sulfur compounds and carbon dioxide will be recovered through molecular sieve. Okay, through this graph, you can clearly identify that molecular sieve is preferred compared to the zinc oxide, sulfatrate, and iron sponge process in a solid bed process. While we talk about chemical solvent, see, chemical solvent, it depends upon the investment of the solvent what you are going to do. See, I can invest 10 rupees and I can invest 100 rupees. Depending upon the investment, we can use specific type of solvent. Okay, but almost all the solvent removes the same compound. Can you able to see bonethanolamine, diethanolamine, methyl diethanolamine, then diglycolamine, diisopropanolamine, and hot potassium carbonate. Okay, except MDEA, almost all the other 5 solvents remove carbon dioxide, H2S, hydrogen sulfide, then mercaptan. No, mercaptan is not removed by any chemical solvent. Then carbonyl sulfide and carbon disulfide. Only monodiethanol amine, that is methyl diethanol amine, it removes only H2S. Okay, it is not fit to MDA is not fit to remove CO2, RHS, COS, and CH2. Okay, these questions will help you in the quizzes. Okay, so make a note of it and remember. When we talk about the physical solvent, we have fluor solvent, shell sulfinol, selectol. Okay, these fluor solvent, shell sulfinol, and selectol will work in a similar pattern like a molecular sieve where it will recover all the impurities present in the natural gas. While rectisol solvent will work similarly like an MDEA. It will remove only the H2S present in it. When we talk about the direct conversion, we have cloth, locat, and sulfur which removes H2S. Now, question comes is in almost most of the industries, direct conversion process is preferred compared to the physical solvent, chemical solvent, and solid bed process. Why? What is the reason behind it? See, almost in most of the natural gas uh, extracted from the reservoir, hydrogen H2S is the major impurity that is present. Okay, you will not find mercaptans, you will not find carbonyl sulfide and carbon sulfide at all. Okay, you will not find even 0.1% there. Okay, most of the reservoirs will give you a natural gas containing H2S and CO2. Okay, CO2 can be recovered, but H2S is the major impurity that has to be recovered. So, direct conversion process, okay, even if the investment part is high, there is no much maintenance cost like what we have in physical solvent, chemical solvent, and solid bed process. And second thing is the best process that is preferred in almost all the industries is cloth process. Okay, cloth process is employed everywhere. We are going to study what is cloth process and how this acid gas is removed from the cloth process. There are from direct conversion process, the same continuation has been mentioned here. We have Stratford, sulfur check, the Nash process, then gas permeation process. Okay, almost it will recover H2S, and the gas permeation process means you will have solvent, okay, in an absorbent. Okay, you will have an adsorbent in which the solvent is added. So this adsorbent will absorb this carbon dioxide, while the solvent will recover the H2S present in it. So this is called as a gas permeation process. This graph I have mentioned it here. Okay, that will give you the what is the percentage of what proportion in what extent H2S and CO2 removal is found to be more efficient. Okay, this you can go through it. I will upload this PPT just for reference. I have mentioned this slide here. Now we are going to study ion sponge process. Okay, just a minute. Okay, when we talk about the ion sponge. Okay, here what we do is you can able to, this is the setup here. We have a pressure gauge, gas inlet, relief valve is the platform, then we have a manway, internal cone is there, then gas outlet, then another manway at the bottom, finally we have support. Okay, we have a ladder. Okay, if a manhole and the ladder is this, obviously it means a person has to get inside this column, inside this tower, and he has to clean and come out. Okay, this is the oldest process which has been designed. Okay, there is no automated one here. All these will be carried out manually initially, but even if it is automated still, but it is not preferred or it is being employed in any industries now. What is the iron sponge process? Okay, here the term sponge indicate wood chips. Okay, the wooden chips will be used as a sponge here. Okay, which is filled here. Okay, this wooden chip will be coated with iron oxide. If okay, this wooden chips will be coated with iron oxide. What it will do is, once you have pumped the natural gas containing acid gas through a gas inlet here, okay, make sure that the temperature should not exceed more than 49 degree. Okay, more should not exceed more than 49 degree Fahrenheit. Okay, what will happen if the temperature exceeds more than 49 degree Fahrenheit? If the temperature exceeds more than 49 degree Fahrenheit, it is not possible for you to control or maintain the pH within the tower. Okay, but you have identified that the temperature has increased beyond 49 degree Fahrenheit. In that case, what you need to do? Okay, you need to add sodium carbonate, Na2CO3, sodium bicarbonate, NaCl. Okay, almost all the salt related to the sodium is added to maintain the pH within the tower between 8 to 10. In the internal cone, what you will have is you will have a layer of wooden chip. Okay, this the top surface of the wooden chip is coated with the iron oxide. Once again, you will have a layer of wooden chip with a coating of iron oxide. Likewise, you will have 3 to 4 layers. Okay, likewise, you will have 3 to 4 layers. Once you started pumping the natural gas containing acid gas, what will happen is the H2S present in the natural gas will react with the iron oxide present in the wooden chips. Once again, I am repeating, the once you start pumping the natural gas inside, what will happen is the H2S present in the natural gas will react with the iron oxide present in the wooden chip. Okay, this H2S will react with iron oxide to form iron sulfide. It means the sulfur present along with the hydrogen will be separated and the sulfur will react with the iron. It forms iron sulfide. Okay, iron sulfide and the water is formed. The important thing is here the water is formed. Okay, whatever the water is being formed, it can be drained at the bottom. Now the question comes is, when you drain water at the bottom, if there is any situation that whether the natural gas, whether the sulfur or the natural gas will come out along with the water, no. A provision had been made in such a way that only the water will be coming out, a filter is there, and the other things, everything will be retained in this internal cone unit. Okay, once you have uh, separated the sulfur from the hydrogen, it means now you have iron oxide is converted. Once the sulfur is removed, what you can do is you can send the natural gas out. This is the gas outlet. Okay, this gas sulfur present in the natural gas, what pump the natural gas out. Now what you have, the wooden chip will have iron sulfide. Now my ultimate objective is to separate the iron and the sulfur present in the iron sulfide. Now I have FeS. Now I have to separate Fe and S separately. What I need to do in order to separate? Okay, what it will do is, I will pump the air. Okay, once again, after recovery of the natural gas, what I will do is I will pump the air. Okay, this gas inlet I have here. Then this first initially what I did is I pump the natural gas here. In the second gas, after I recovered all the natural gas out, I will pump the air. Okay, this air is void of nitrogen. Okay, it means you will have only oxygen. Okay, make sure that you have to supply oxygen very slowly. What will happen if I supply oxygen very fast? See, you have a wooden chips here. Okay, if you supply oxygen very fast, okay, the wooden chip will start igniting. It means, okay, the wooden chip will start igniting if you start pumping the air at a faster flow rate or at a high pressure. So what you have to do is you have to always supply the air at a low pressure. Okay, make sure that steps are taken. If you supply the air at higher pressure or if you supply the air very fast, okay, the wooden chip will start igniting. It means the fire tends to form. Okay, if the fire tends to form, okay, it will cause an explosion. So make sure that, okay, no accident is being happening while this operation is taking place. Once you start pumping the air, now what will happen is the iron present along with the sulfur FeS is there. This FeS will react with oxygen to form iron oxide and sulfur. Okay, initially we used iron oxide to remove the H2 and S. Okay, once you have converted the iron oxide to the iron sulfide, once again I am adding oxygen. What it will do, this oxygen will react with iron. Now once again I will have iron oxide and sulfur. Okay, the sulfur will be collected as a cake. Okay, now the question comes is, once I recovered the sulfur, it is not possible, whether it is possible for me to remove immediately. No, it is not possible, unless otherwise the sulfur cake is formed for to a size of 3 mm. Okay, unless otherwise a sulfur cake is formed to a size of 3 mm, it is not possible for you to collect the sulfur cake at the bottom at all. Okay, they have designed this tower in such a way that, okay, only if a bigger sulfur cake is formed more than 3 mm, it is easier for you to collect the sulfur cake. Okay, if you have a sulfur cake layer of 1 mm, whether it is possible to collect? No, it is not possible. You can able to collect the sulfur cake only after a 3 mm sulfur cake has been formed, or greater than 3 mm size. Okay, this is the iron pond process. Okay, in iron pond process you add iron oxide to remove the sulfur present in the natural gas. So iron oxide is converted to iron sulfide. Once again you add oxygen. Once you added oxygen, what will happen is, okay, the iron sulfide react with the oxygen to form iron oxide and sulfur cake separately. Okay, this sulfur cake can be collected at the bottom. Once you have collected the sulfur cake, now if there is any provision for me to carry out the regeneration, because we have used wooden chips, we have used wooden chip. Okay, this wooden chip has been coated with iron oxide. Okay, so if there is any provision for us to carry out the regeneration? No. Okay, you have to replace a new bed. Once again you have to replace a new layer of wooden chip with a coating of iron oxide. Okay, so it means it increases the investment cost, it increases the maintenance cost, and it increases the operating cost. That is the reason why iron sponge process failed, and we go to the next process. I have included almost all the explanation there, so you can read it. Then we have a sulfur treat. Okay, this sulfur treat process is similar like an iron sponge. Okay, here also we will use the iron. You can, in the second para you can able to see, sulfur treat utilizes a proprietary iron oxide co-product mixed with an inert powder. Okay, mixed with an inert powder. Along with the iron oxide, you will have an inert powder for the recovery of the sulfur. See, in a solid bed process, in the iron pond process, first you have recovered only the H2S. We haven't recovered carbon dioxide at all. It means no provision is there for us to recover the carbon dioxide present in the natural gas. Okay, here we have an inert powder. This inert powder will take up the role of separation of the carbon dioxide, while iron oxide take up the role of the separation of the sulfur present in the natural gas. Okay, this reaction here, the sulfur treat process also utilize the similar column like an iron pond. Okay, in an iron pond process, you had a temperature of around 49 degrees. Okay, here you will have a temperature of 54.4 degrees. Okay, make a note of it. In iron pond you had a temperature of 49 degrees. In sulfur treat process we have a temperature of around 54.4. Okay, here we don't have any difficulty like to maintain the pH. If you want to maintain the pH, we need to add